Okay, so today I'm going to talk through this 6-mark question. It's part of the electricity topic for GCSE physics in the AQA exam board. And the question is, explain how the readings on both meters in this circuit change when the environmental conditions change. Now, I'm going to talk through this because it's when you break it down, this question has a lot of components or aspects that you need to understand, which make it seem quite difficult, but in fact, it's not. So the first thing you need to know or understand to be able to answer this question is how LDRs or light-dependent resistors work. This is the component that you see me circling here. The second thing you need to understand is how current and voltage vary or change with resistance. So as resistance goes up, what happens to the current and what happens to the voltage? And vice versa, if the resistance goes down, what happens then? And then the third thing you need to know for this question is that voltage from the cell, okay, we know that this is one cell. If it had loads of little lines, it would be a battery which has multiple cells in it. Voltage in a circuit is constant. What this means is that in certain parts of this circuit, the voltage, or another word for voltage, the potential difference, okay, so I'm going to use those interchangeably, the potential difference across certain components may increase or be higher or decrease or be lower across certain components. But overall, the overall voltage or potential difference that's coming from the cell has to be the same. So if it's higher in one place and lower in the other, overall, when we look at the circuit, it should remain constant. It should even out. Okay, so let's have a look at the 2 meters that the question is asking about. Those are here. You've got the ammeter here and the voltmeter. Now, I'd just like to point out that ammeter is spelt E-M-M-E-T-R, not A-M-P-E-T-R. Some people think it's an amp meter, okay? That's not a thing. The reason they think that is because the ammeter measures current and the unit it measures current in is amps. So they put the two together and they say amp meter, but it's an ammeter. There's no P in it. And the second meter is the voltmeter down here. As you can guess, it measures the voltage, or another word, potential difference, in the circuit. And there's 2 more components that I want to draw your attention to. The first is here. This is a fixed resistor. This is what it looks like in real life. And what this means is, a fixed resistor has a fixed resistance. I could choose a fixed resistor of 20 ohms or 30 ohms and put it into my circuit, okay? But the resistance that it provides stays the same. If you wanted to work out because it doesn't say the number here of the fixed resistor, it doesn't say how many ohms. It's quite complex to work out what resistance the fixed resistor is, and you have to use the colours on the band. You don't have to know this for GCSE, but you can pause the video there if you were interested in looking at it or working it out. And the second component I want to draw your attention to is the LDR here, or the light-dependent resistor. In short, the light-dependent resistor, the resistance that it provides depends on the light, or the light intensity. So when the light intensity decreases, when there's not a lot of light intensity, the resistance increases. And when the light intensity increases, the resistance decreases, okay? They work in opposition to one another. So let's break this question down. It's asking us what happens to the readings on the ammeter and the voltmeter. So in order to know this, we really need to know what the relationship between current and voltage is. So I'm going to go back to this equation. Now, I've got this equation triangle here. You should know how to use these. Just to recap, if not, you cover what you're looking for. So if I wanted to know voltage, I've covered voltage here with this circle, and it tells me that voltage equals, or is equal to, current, that's here, times resistance. And I've written that out here. Voltage equals current times resistance. Now, I'm going to repeat this a few times in the video, okay, because it's important to remember. The voltage, or the potential difference in the whole circuit, has to stay the same. So whatever's being pumped out, whatever voltage is being pumped out at the cell, it has to be the same amount going back in. So this has got to remain constant. So if the resistance is decreasing, the current has to increase because the voltage needs to stay the same, or vice versa. If the resistance was increasing, the current is going to decrease because the voltage, again, needs to stay the same. I've got this little cartoon here in case it helps you. You've got the little yellow voltage here pushing the current through, and the resistance, or the which you measure in ohms, is working against it here to show that voltage and current are sort of working against the resistance. So we want to see what happens to the readings on the ammeter and voltmeter if you've got a light dependent resistor in the circuit. So we're going to go with this bottom example here, when the light intensity increases. This is the scenario we're going to talk through. So if the light intensity increases, we know that for an LDR, the resistance decreases. So let's look back at here. Therefore, if the resistance decreases, the current has to increase. So this is going to look like this. If the current is then increasing, you're going to have a higher reading on your ammeter, which measures the current. And I've just put some symbols up here to try and help you. So the more light there is, as light intensity increases, this causes the resistance to decrease. As a result, the current increases. So you can have a higher measure on your ammeter. Okay, so this is the part where it gets a little bit trickier, because I keep saying the voltage across the whole circuit stays the same. But as I've said before, it can increase or decrease across certain components of the circuit. So here, if we're looking, if we want to know the reading on the voltmeter, whether it increases or decreases, we need to know where it is. So when we look back at the circuit, we can see the voltmeter is placed around the LDR. Now we know that as light intensity increases, the resistance of the LDR in here decreases. So there's not a lot of resistance here. I want you to picture that the voltage that's trying to get through, okay, if there's not a lot of resistance pushing back against it, then the same amount of voltage that's going in is coming out, and the potential difference across the LDR, well, there's not going to be a big potential difference because there's not a lot of resistance pushing back on it. So the reading on the voltmeter is going to be decreased. There's not a lot of potential difference. But as I said before, the voltage across the whole circuit needs to stay the same. So if the voltage across here and the potential difference across this component is decreasing, what it means is that it's increasing across this component here, okay? The potential difference across the fixed resistor is going to be increasing as a result. I think that's the trickiest part of this whole mark scheme to really get. So let's read through what we've already covered that's in the mark scheme. The resistance of an LDR changes when light intensity changes, or specifically, when light intensity increases, the resistance of the LDR decreases. And as a result, the overall resistance of the circuit decreases. The potential difference across the total resistance remains unchanged. Basically, the potential difference, or the voltage across the whole circuit, doesn't change. It changes across certain components, but across the whole circuit it is the same. The current in the ammeter increases. The potential difference across the fixed resistor increases. We know this because the potential difference across the LDR decreases. And because the potential difference across the LDR decreases, the reading on the voltmeter decreases. Now, these 3 points here aren't sort of extra points. I think they're just stuff you really need to know in order to have grasped this in the first place. So the potential difference is shared between components in the series. We know this because it's like a seesaw. If there's more potential difference across one component, then it's going down elsewhere because voltage stays the same across the circuit. The lower the resistance of the LDR, the smaller the shared potential difference. So if you've got less resistance, this is just another way of saying what I've said before. If you've got less resistance pushing back in the LDR, then it's going to take up a smaller share of that voltage or potential difference, and the potential difference across the resistor, the fixed resistor, is going to increase. Okay? And I think that is everything. This is just a doubled point up there, so let's ignore that. So as you can see, it's quite a complex question, but when you break it down, it's not that complex. So let's talk through if the opposite were to happen. So if there was less light, okay, the resistance would increase. This means that the current would decrease. And remember, voltage stays the same across the whole circuit. So if the resistance is increasing here, there's more resistance pushing it back against the voltage. So the potential difference across here is going to be greater. There's going to be a bigger difference. Because the current decreases, we know the ammeter, which measures the current, is going to have to decrease as well. And as I've just said, the potential difference across the LDR, because it's put around the LDR, is going to increase as a result. So I hope this video has helped you. I hope you've gone from maybe not understanding what the question is asking for, or what you need to really include to get those 6 marks, or where even to start structuring this question, because there has a lot of components to it, to now understanding all the different parts that you need to hit. So I've highlighted in this mark scheme the different points that talk about resistance, potential difference, and current, in case that is helpful also. And I hope this video was helpful.